Have you ever been sitting on a plane just waiting to take off and wondered about the invisible web of coordination that makes it all happen? It's not just about the planes, it's about the people. Today, we're going to pull back the curtain on the amazing database systems that are the unsung heroes of aviation, the ones that solve the massive puzzle of scheduling every single flight crew.
I mean, really think about that for a second. Thousands of pilots, thousands of flights, all day, every day. You might think, oh, it's just a schedule, right? No way. This is a mind-boggling, high-stakes database puzzle, a complex dance of data that has to be perfect, or the whole system grinds to a halt.
All right, so here's our flight plan. First, we'll break down the puzzle itself. Then, we'll look at all the data, the ingredients that go into solving it. After that, we'll see how the master schedule, or roster, actually gets built. And, of course, we'll see what happens when chaos strikes. Finally, we'll take a look back at the incredible history of this technology.
Okay, so let's get into it, the unseen puzzle. This is all the stuff happening behind the scenes. We're talking about a ridiculously complex web of rules, hard and fast regulations, and just the constant, relentless change that is the reality of air travel.
So, to even begin to solve this puzzle, the database needs all the right pieces. Let's talk about the ingredients. Before a single pilot gets assigned to a single flight, the system has to be fed a huge amount of data.
And what kind of data are we talking about? Well, for starters, you've got qualifications. You can't just stick any pilot in any cockpit. You need to know exactly who is certified to fly a 737 versus a 787. Then there's the big one, the legal stuff. There are ironclad rules about rest periods and how long someone can be on duty. That's all about safety. You also have to factor in where a crew member is based, their seniority, which is a huge deal, and even their personal preferences. And all of this has to be juggled in a system that can handle real-time disruptions. It's a staggering amount of complexity.
Okay, so we've got all our ingredients. Now it's time for the database to start cooking. This is where it takes all those millions of data points and starts weaving them together into the master roster, the schedule that keeps the entire airline in the air.
Now, to really get this, you have to understand a key concept, the pairing. A pairing isn't just one flight. It's more like a mini tour of duty. It could be a 3-day trip that goes from New York to London, then to Paris, and then back to New York. That whole sequence is one unit, one pairing. Think of it like a Lego brick. It's the fundamental piece you use to build the whole schedule.
And that brings us to the roster. If pairings are the Lego bricks, the roster is the final, incredible Lego castle. This is the master schedule. The database takes thousands of those pairings and clicks them all together perfectly for every single crew member, balancing everything from flight coverage to costs to, of course, all those legal rules.
But we all know that travel rarely goes exactly according to plan, right? So what happens when that beautiful, perfectly built roster runs into the real world? This is where the database goes from being a planner to being a first responder. Just picture it. Everything is running smoothly. The system is humming along. And then, bam, a massive thunderstorm grounds every flight at a major hub like Dallas. Suddenly, that perfect plan is torn to shreds. And what happens next is just incredible. The database doesn't panic. It instantly kicks into gear. It identifies every crew that's now stranded or delayed and starts calculating new routes. At the same time, it's searching for available reserve crews who are nearby and qualified. And through all of this shuffling, its #1 priority is making sure no one exceeds their legal duty limits. The whole master roster is updated in real time. It's just wild.
And that's because a single change is never just a single change. It's like throwing a stone into a pond. The ripples spread out, affecting other flights, other crews, passengers waiting in another city, and as this quote says, even people's paychecks. The database is the only thing that can manage that massive, chaotic chain reaction.
Now, this kind of automated, intelligent response, well, it's pretty modern. It wasn't always like this, not even close. So let's rewind the clock a bit and look at the evolution of how we got here from the very beginning.
I mean, just look at this journey. In the past, this was literally done by hand. We're talking about giant boards covering entire walls, with people frantically moving thousands of cards and pins around. Can you imagine the stress? Today, we have these incredibly powerful optimization engines that can analyze millions of possible schedules a second. And the future? It's all about AI and real-time data feeds, systems that might be able to predict and solve a problem before it even happens.
So at the end of the day, what we're looking at isn't a static file cabinet. It's a living, breathing digital brain for the airline.
It's constantly performing this high-wire act, balancing the absolute necessity of safety, the business need for efficiency, and the messy, complicated reality of thousands of human beings.
And that leaves us with one last, pretty sobering question. We've seen how this system is the invisible backbone of air travel. It's the central nervous system keeping everything moving. So, what happens when that backbone breaks? What happens to all of us when the system just fails?